Anders, last time we left Lisbeth, professor at DTU here, and talking about reusability in structure, construction. But what's up with Lisbeth?
The thing is with Lisbeth Ottesen, Professor Lisbeth Ottesen, is that I've known her for 10 years. Yeah. And she's always been fantastic at being like, you know, the people that actually are wearing a yes hat all the time and knows what she's saying is right. Okay. So when I had problems with, I wanted to recycle concrete. Yeah. And I couldn't understand why you couldn't just crush existing concrete and actually recast with it again. That was the idea 10 years ago of recycling all the concrete that you would otherwise put in the ground. Yeah. And then I found Lisbeth and she was like, yeah, no problem. And she already had tests also with crushed brick that could be recasted and used instead of cement. And she has all these fantastic materials and tests out here at D2. Okay. So she is one of the...
One serious, fantastic lady.
She's so smart. She's so smart.
You are the pioneer lady, professor, genius of trying to find materials, new materials that can be used structuring-wise, right?
Yes. It is materials for the future.
Yeah.
Because we cannot keep doing what we are doing today. We are simply building with the wrong materials. Okay, we are driving in the wrong direction with the globe, and we need to do something new. Yeah. So we need to relearn a lot of stuff, and that includes making new materials. Okay. And there's absolutely nothing wrong with the materials that we use today, except for the environmental issues.
Should we see them?
Yeah, I can show you some of them.
So if you this is the first program you're watching, go back and watch the other program where we go through the reusability of existing structures, right?
Good idea.
But this is cool because I'm guessing we're also going to see some tests of these things, right?
Yes, we will.
Okay, so show us the future.
We should vision that we are moving from where we are now, and I'll try to take you from where we are now, and some steps into the future. Okay. And we need to make sure, we'll have to have one foot on the ground still.
Oh, so we're not levitating?
Because we are human. We are human, so we'll have one leg at the ground, so we are moving safe, because we were talking about structural materials, so we need to make sure. We have gravity. We do. And also therefore, I would like to show you something. I got something here in the box. I have, for example, different materials here. Okay. And these are, what we need to do is that we need to save resources from nature. Yeah. And we have so much waste, so we need to make products out of the waste. That's not new, that's circular economy. But these are examples of things where you can do it.
But this is a brick,
This is a brick, but it's a special brick because 40% of the natural resource, which is clay, is replaced with sewage sludge ash.
So what's sewage sludge?
I don't think too much about it. Yeah, don't think too much about it. When you flush the toilet, something runs out.
Brick. Yes, this is like shitting bricks. It's a shit brick.
Yeah, you can call it that. You're welcome to call it that. The brick will not pay attention.
Yeah. No.
It's not sensitive.
And you can also say this is a resource which we will probably not get rid of.
The shitting.
Flushing thing. And in some areas it's incinerated because we have too much of it. It can be spread on farmland, but here in Copenhagen area we incinerate it.
Yeah. Copenhagen shit.
Copenhagen Shit Bricks.
Yeah, you could say that.
It's a great name.
Yeah, it is.
It's a big production.
Copenhagen Shit Bricks.
Yeah, I think a lot of people will buy it.
CSB Bricks. That sounds very serious. Sounds like a material company. Yeah. Okay, so how did you do this?
But this one is made actually on a brickwork. Where we have a test, where we did a pilot test where we made these bricks, and it seems like it can be done very well.
You collect the things.
Yeah, this is ash, so it's powder.
Okay, so it comes
from powder. It's red powder.
But one thing I just have to say, Anders, what is important with this, and what Lisbeth is doing here, is that she's looking at, maybe it's wrong, I would call it secondary waste fraction, right? Yeah. Because it's shit. Yeah. Like we've been looking at building materials, then we go like to the next level of things that are not usable for anything, and then Lisbeth is making it usable. Yeah. So what holds the shit together, to say it a little bit more directly? Because usually with bricks, the problem is that we burn the shit out of clay to make it hard.
Yes.
That's the CO2 emission, embodied energy in it.
Yeah.
What do we do here?
It's actually exactly the same process, but we are
so
not...
we're just burning shit now?
Yeah, you could say it was burned before.
So the only thing that we're saving is the
clay.
The clay.
But clay is also a scarce resource.
And when you talk about clay, can we put it here? Because I think
you want to go over there.
I think the shit
I'm gonna
brick,
take this.
I think the shit brick needs to be center stage, right?
We discussed this so many times, and when we did, I just explained, which you didn't hear. But I said when we are recycling concrete, where we are crushing it, we are using new cement. So we were again using a resource, a lot of waste concrete, but we had to use cement, which is again a little bit the same here. So we're taking the volume, the scarce resource, clay, and finding some other clay, but you still have to burn it. Have you tried to mix it up with salt and minerals, so it actually have a kind of chemical reaction together with the shit?
No, we have not done that with the sewage. No, not with the sewage sludge. Yes,
it's some Swiss material, like I think they call it clay tech, something like that, which is you only put 2% in it, and then it starts to harden up.
Yeah, no, we have not tried that.
We'll come back, new program, Lisbeth. You're going to be in all our programs in the future.
But I just wanted to.
Okay.
So this. No, but because this is an outside brick, right? This is a brick that will, and this. Do you guys know if all the standard is, the standard of a brick is being kept here?
Yeah.
Okay.
This could be done, but I would say something before, and that is that we need to remember that this sewage sludge ash, it is not only the ash. There is actually something which is a major scarce resource, and that is phosphorus. So we cannot just take it. Phosphorus is a scarce resource, and that we are afraid of a crisis. The whole world, we need it. We can know without phosphorus, no life. So therefore, we need to take it out before we
is the phosphorus in Greenland?
No.
Now Trump doesn't even want it.
What is this one? You've been.
That is actually concrete with the same sewage sludge ash. But it
also keeping the standard, the existing standard.
Yeah. This one is also.
But still, you have the phosphor problem again.
Yeah, but we can take it out. We have developed and also a patent on a method to take it out. That was why it was important for me to say it.
Why are you not super rich? Very often, guys like you, also you, Karoline, you know a lot of things. You have these. You've developed these new materials, and then I'm often thinking, why are you not? Making a business and you're scaling it with somebody and getting super rich so you can kind of speed up this knowledge.
But I actually think it's it's actually a very good question.
Do you know this is the second program in a row where you say that I'm doing good questions?
Yeah.
I'm just saying.
Yeah.
But why?
I think it's because we have other value types. I think the happiness. Yeah, you're smiling. It's because the happiness lies in actually doing that.
Yeah.
Okay.
And it's not what comes after. The after thing is sort of for us. After that is going to improve that one. So that is what comes after, doing it better and better and better. So it's that's why we need to meet. People from universities. No. I was not pointing at you, but we need to meet. And then things will happen, because for me I'm back again. It's not. I'm not. Forward for me is to find a better and a new material. So I think
it's also what you love is developing this technique.
And also,
sorry.
But she also really likes to get stupid questions from guys like me, for instance, from the industry, from the other side, because we are thinking like, why is this not possible? Then we don't have things like this, and we don't have heads like Lisbeth in architecture offices or engineers in that same way. And then, not to say like why you are not the one making money, but it's just also to remember that the whole value chain, it's really complex, and there's so many stakeholders. So one thing I always say, coming up with a great idea and showing that it works, it's just a little percentage of actually succeeding. So I mean, from that brick, unfortunately, that's a problem for the whole climate change. There is like 5 to 10 years ahead for this to succeed. And every time we have these innovations, it takes so long to kind of unfold them to become, a lot of bricks.
But the thing is here, Lisbeth just explained, you have a technique, you have abundant resources to replace clay. You have a patented technique to take the phosphor out. Yeah. This is something people just could take now, put into production and scale, right? Yeah. And
invest in it, I would say. That is probably
but it would also be, what do you call it? Will this be cheaper than existing brick because you're using a different materials? It's not clay.
I think it would be the same price.
Okay.
So that's also good.
But did somebody already take the idea? Have you given the idea to somebody to say, make it?
We need to make it, well, this could be done, but then we will cast the phosphorus in there, and I don't think that's a good idea.
No, but you have the phosphor idea.
I do have it, but that plant needs to be built before they can actually deliver.
Okay, so what is else in store for the future?
I would like to show you, where did it go, my picture? This could be the future. This is a future material, and now you see I'm only standing here with the picture. And this is because the real thing is standing in the design.
Could we just for the excitement go to the robot here?
Is the robot here?
There's a robot down there.
Where is it?
It's not the same robot, but it could have been the same. This one is the replacement for that one.
What is it that we're going to look at, Lisbeth?
It is a new material. It's a concrete, but there's no cement in it.
Oh.
And that you can now hear that now we are talking CO2 savings.
Now we're waking up.
Yes, now we're talking, and it's made the robot. This is a replacement robot, but it was made
on. This robot is called Torben.
Yeah,
very Danish
let's call it the Torben. And what it is that this you can see here. It's actually 3D printed. This is Torben 1. This is Torben 2. So this is an old robot where we printed shapes like this. Yeah. And what is most fantastic is that you can, it's actually more things. No cement in this one.
Fantastic.
And you can 3D print it. What we started out with was waste from fishing industry in Greenland.
Oh, yeah.
We had this fantastic PhD student who liked Greenland a lot, and in Greenland you have resources. We can hear that Trump is interested, but we don't have resources to construction materials. And therefore he went around there and thought, what do they have a lot of in Greenland? And that is waste from the fishing industry.
Are we talking skeleton and bones? Or?
Yeah. Okay. And what you cut off when you, I guess also what is in the stomach of fish, such things.
And there's a lot
of that. Yeah. And then he just thought, I want to make a construction material out of that. So I think there was that's what I mean, that sometimes...
Yeah, when you don't have any, when you're scarce resources, you use what is there, and then you come up with new innovations. Yeah. That's wonderful.
But she's very fun. First the shit thing, and then now the thing that comes before the shit thing.
Yeah, you're right. Don't think of what it looks like. It is still a concrete.
I was actually not thinking that.
No, that's good. I was.
Escape
it. And now it's coming out here, and now it's heated to 70 degrees, and when it hits room temperature, and then it hardens immediately. So it's totally different than normal concrete, where it hardens over many days, and that's why you can actually print. You can print a lot of different shapes.
And this has the same capacity, the same.
It's extremely strong.
So
it's extremely strong.
And what is the binder instead of cement here?
It can be. The first one was fish glue, but it can also be bone glue. It just needs to come from organic matter.
Glue.
Yeah, bone glue and fish glue, and that is actually not a new product, because that has been used in conservation of furnitures and such stuff for very long.
And so, 3 things: CO2 saving on this.
Yes.
Type of concrete you can make with this, and the economy. Yeah.
I can. It's still in this scale, you could say. Yeah. And I would like to say where it can be used, because we started to make it for Greenland and actually to mining villages. The idea is that this one, you should be able to build a mining village, because we know in mining areas there's a lot of, dead cities. We can see it in front of us. The idea is that you bring your, what was it, Torben? Yeah, you bring Torben to the site, and then you have the fish glue in tank, exactly. And then you bring it there, and then there will be sand next to the mines. So you just use the local sand. Yeah, it's sand and bone glue. And you bring Torben, so you don't need a lot of tools. So you can simply build a whole village from this.
And you don't need any steel or any...
No. But here you would need a roof if it's raining, because it's not durable. as it is there. It's then you would put a roof, and then you would live there while you're doing the mining. And when you finish up mining, there will not be a wound like this dead town anymore, because you just remove the roof, and then after some years it will just be a bunch of sand again.
So the idea is here that it dissolves?
It was the first idea, that you ask what it can be used for. So this was the first idea. The first idea was that this one is one where we give it back to nature. We use it and give it back to nature. So this was the first idea, and then we started to 3D print things like this, and then some other people started to get interested, because it actually, as I said, it is extremely strong. So therefore you can say it has this mistake, yet it has this, failure. It is not durable if you put it out in rain. You need to cover it, so it's exactly the same as with the clay we looked at before. It is not durable outside.
But you have techniques in the backhand to make it durable outside.
That is what we're working on now.
Now?
Yeah. Well, at present. But it's, I would say, indoor you can use it. And for example, 80% of the in a building is actually indoor. So we could replace maybe 80% of the concrete, and then we could only use.
So basically, if you had a rain screen facade on it, securing no water to come.
Yeah.
Hit it
no
in
water,
then
that
would
safe.
be fine.
Yeah.
So this one could actually replace the core in tray. When we look at tray, you have the core with the elevators.
The core, but also, I mean, that's an indoor part of the building. So of course, but you could also, have it as the back wall, like a classical element. You have concrete, then you have insulation and brick or facade. Check. So you could have it as a load-bearing back wall. Yeah,
just to make very sure that no water is coming there, then we can trust it. And actually, I do have colleagues who are also figuring out how do we reinforce when we 3D print.
We know you have some of your assistants working right now on stress testing things.
Yes, they are
Should
just
we go and look
here.
at that?
Let's go and take a look.
Thing?
Yes, let's do that. It's
Fantastic.
just over here.
Always cool to go into a lab, right? And so what's going on here? Oh, it's people we know. Katja Zakhan, yeah?
We have multiple testing machines, great capabilities. We have 2 MTS with different load capacities. This one has 600 kilonewton and this one 100
So
kilonewton.
don't put your hand in there.
Don't put, yeah.
Okay, correct. Okay.
But the one that you should definitely be aware of or be careful of, this one. Because this has capacity of almost 3 meganewton.
Mega what?
Yeah, too many zeros. 3 meganewton, because it was this one was 100 kilonewton and this is 2008, like 2.8
so it can press shit together.
Yes. So we are using to press the concrete cylinders or any other materials to find out how much load they can carry.
Is there something you also do, Katja?
From time to time.
Come over here.
Yes. So the idea is the non-destructive methods that we made on the concrete columns, on the structures, on the cylinders, we are correlating with the destructive test. This is a destructive test because soon you will see...
Are we going to destroy that?
Yes.
Katja, explain what we're doing.
Yes.
You're locking it.
We're locking it.
And why are you guys destroying
Lock and load.
What is it that we want to find in a destruction?
So with the non-destructive testing, you can tell something about quality, but it's all quite relative. You can say, is this better quality than the other? But in order to put a concrete number, so to say, on the non-destructive testing, when we're talking about strength and these kinds of things, then we need to do some destructive testing on some cores to correlate
it is a
the
destructive
data.
test, because
This is
I was nearly getting,
worried that we might not break it.
Exactly.
So for instance, like if you wanted to do a floor, and your client says, well, on this floor I need, to pull my plane in, my trunk plane, something stupid like that. Then you need to know how much pressure the floor needs to be able to take.
Okay.
And that's what you can figure out with that.
Okay. So this is a blend of concrete that people are suggesting that we will build as a floor for planes.
Yes.
And
Correct.
The thing with concrete is that it will vary in strength according to some areas might have more aggregates than others, some might have more cement content. It also depends on how well it's been mixed and vibrated through
I come back to that and
period.
tell you an anecdote of where I'm living, and there is a structure that is actually fucked up due to that. But,
Okay.
but so let's destroy this shit.
Let's destroy this. Yeah.
So you
go into PowerPoint.
You're doing it.
That's the hydraulic power. Hydraulic.
It's coming.
Now the head is coming.
Oh shit!
How much pressure is that?
We can tell.
Almost
So this is
3,000.
3,000. No. Wait,
3 Newton. Boom.
Okay.
You guys.
Through mega Newton.
So this
You
is,
guys are doing this also just for fun.
yeah,
Just for fun. Yeah.
Are
So
you-
this one that was 320,000 Newton. So
That's a lot, right?
320 kilonewton.
And so
it's a beautiful
and so the reason why we wanted to show this, Sakana and Katja, is that you take existing ways of doing things, right? And then Lisbeth and Karoline, I guess, is coming over with new stuff, saying,
Yes.
"Can you put this into the machine and test it, right?"
New materials, yes.
To see, so compared to this one, right?
Yeah.
Okay.
See, okay, can you do this
Good
in a
point.
more sustainable way while also maintaining the properties that we want?
Okay.
Yeah.
Out where I'm living, there's this huge high-rise, and it has been stopped midway in construction because there was a problem with the concrete. Do you know what building I'm talking about?
I think so. Is it the one with bicycles also in? They found some
Yeah,
bicycles
exactly.
in the
Yeah.
concrete
They
mix?
found they found bicycles.
Yeah.
They found all kind of shit in the wall.
At least I don't know if it's a myth or not. But
No.
yeah.
I don't think it's a myth. Do you know the building?
I know the building. Yeah, it's very scary. The concrete entrepreneur contractor, he wanted to save money on aggregates and kind of the concrete. So it's basically just waste and not enough cement and casted a high rise, which is actually there. So it's a huge problem trying to figure out how to make it strong enough for anyone to live in it.
Wild thing is that it's also a crime thing.
Yeah.
The CEO of the company or the salesperson is killed or allegedly he's
killed.
He's
in the concrete.
No. He's in a car crash or something like that, and it's
they
labeled
should
as
do
a suicide or something.
They should do
like
a true crime about
it
this.
is super true crime material. This thing.
So.
And just show that this is super important.
Let's check with the new materials.
This was on an ordinary concrete.
Okay.
We find out the compressive strength.
This is Lisbeth's. This is yours.
Yeah.
Lisbeth, come in with yours.
Is this your fishbone brick?
No, this is not. No. We
The
don't
shit
do
brick?
that, but then we are 3D printing them, so I don't have so
This
many
is
of
the
these.
shit
As I
brick.
told you, this could be a shit brick.
This is a recipe. In here, as you can read the label also, we are going to do flexural tests. Because for concrete, we needed to know the compressive strength, because that's what is designed for. And for this type of material, we would like to know also flexural strength, which allows us to know how much this brick or this material can carry without bended too much or fail due to the bending.
So why this is important, and that's also for the other program where we were actually talking with you guys about the standards. So this is a way to figure out if your new products lives up to a standard.
Yes.
Yeah.
If they do, we can just use them in the building sector, right? So that's the key, that these tests opens up for us to use new materials, new innovations directly in the buildings legislation, even though it's a new type of material for most parts of it, right?
Yes. And I would say that, to add to that we do make materials which do not live up to current standards, but we need, in the future, we need to learn to use materials with different properties.
And when are we gonna smash this shit up?
If it can, we're going to be so disappointed.
Is it going at it now?
Yeah, but
It's a very silent machine.
Yes, compared to that one, because that one has huge power.
And watch it until it breaks.
Go closer. Go closer.
And the thing is, it's testing the.
We have to go in.
The bending.
Yes.
No, so it's not, okay. Now I know the flexing.
Since these are very sensitive, they go very slow. If you wait that one, I will accelerate the process for you, so you can see the real shit. Now it's going very fast.
It's going fast.
Not going very fast.
Is that fast?
That's not fast, I can't.
Yeah, it's fast for material scientists.
It's fast. Oh my god. That's why it takes a long time to develop a new material. Like, that's funny.
Is it moving?
It is moving, and it still has time. You can see the micro cracks actually happening now.
Can you see that?
Yeah, it's bending a lot.
Oh yeah, shit, it is. It is actually.
Now it's coming. The failure is coming.
Look at the screen.
No. Oh. Yeah! Hoppa! That concludes today's program. Thank you very much.
Lisbeth. Thank you.
Thank you for showing us to smashing. Thank you for
I stood up a little too fast. I'm actually losing blood to the face now.
Yeah. Thank you for taking us through all these different new techniques. At the very end, what was it that you said at the very end?
I said you probably made the best jokes, but I'm not the one to evaluate it.
Great. That's not what I heard.
That's